Welcome to the Making Math Moments That Matter podcast. I'm Kyle Pearce.
And I'm Jon Orr. We are two math teachers who, together,
with you, the community of educators worldwide, want to build and deliver math lessons that spark engagement,
fuel learning,
and ignite teacher action.
Welcome to the second ever episode of Making Math Moments That Matter. Are you ready to do this, Kyle?
I am so ready. Let's dive in. So, Jon, what's a quick win for you from today?
Well, you know what? Today in my grade 9 math class, we were working on linear systems, and I had a problem that I wanted to do. I had to, those typical membership problems. It's like you go to a gym membership, and membership 1 has this monthly cost, but this flat rate to get in. And this membership, it might be a straight flat rate, and then this other membership has a different monthly cost, and a very typical problem. I wanted to kind of tackle that thinking about what is the best option between these three memberships. And you know what, I wasn't, I was I guess a little worried about this lesson. I wanted to spice it up a little bit, and I did one little thing. I changed the first thing I wanted to say in front of the kids is I showed the memberships, but I didn't ask any math questions. I just asked one question because I wanted to generate a lot of discussion early on. And I think it went well. All I said was just compare the major differences between these plans. And that was it. That's what I said. And I said, you have a couple minutes to discuss that, jot any of those major differences down. And for me saying that was huge because, and I wasn't expecting what happened is what, a couple pairs of students were writing major differences between the plans and stating, the obvious ones. And there were many groups diving into creating tables right away to show those major differences. And, I had like 3 groups writing equations. I wasn't prepared. I wasn't like fully prepared for what happened right there. And, I thought that was a major win that I got to see exactly what everyone was thinking about this before we even dove into that problem. So it was pretty cool to see today. I was pretty happy. What was your quick win, Kyle?
The one that sticks out for me early in the day, got an opportunity to go and check out a grade 3 classroom with a colleague of mine, Yvette Lehman. And we went to Begley Public School in Windsor. Very, very diverse student population. So we have lots of ELL or English language learners there. And I had the opportunity to go and see Hannah Elmy. She's on Twitter at Miss H Elmy. So the letter H, so MISS, the letter H, Elmy, ELMI. And got an opportunity to check out her math class. She started off with a number talk. It was really cool. It was like a 3x3, maybe 4x4 grid of numbers. And the question was, how many different ways can you make 19 using any operation you wanted? Great chat going on. And then after that number talk, broke into some pretty cool math centers. So she was at the guided, they call it the guided reading table, but really it was the guided math table today. And she was working with small groups of students while others had a variety of math activities. It was a very active learning environment. The kids were loving it. And then when she would have them rotate from center to center, she would use a little bell. And when you hit that bell, or when she hit that bell, you could hear students like disappointed that they had to leave the area they were in so they could move to the next one. I've got a link here, kylep.ca/tweet2, the number 2. So kylep.ca/tweet2. If you want to check out a tweet I shared, it's a video of 2 of her students playing math Jenga, where she had taken a Jenga kit and wrote all kinds of math facts on it. And the students, once they pull a Jenga item,
awesome,
piece, they would be covering the answer and they would be looking at something like, let's say, 6 times 3, and the student would have to say the answer before adding it to the top of the tower. So that's just one tweet of many photos and videos I took while in the classroom. Super cool experience. Like I said in the last episode, love getting into the elementary classroom and learning from my colleagues in the elementary panel.
Awesome. Awesome. That's I love that Jenga idea. I've seen it
Math
somewhere
Jenga.
else, and I've seen it one somewhere else with algebra expressions on it, and you pull it out and you have to do it before you put it on top. That's pretty cool. In episode 1, if you listen to episode 1, we introduced you to our 3-part Making Math Moments That Matter framework, where we want to ensure that we spark curiosity in order to fuel sense making with our students that intentionally and also intentionally ignite our teacher moves before, during, and after the lesson. And today, the purpose of this episode is we want to take some time and chat about how we can spark curiosity with a technique we call the curiosity path.
Beautiful, beautiful. I'm so excited for this, and we referenced it in the last episode. Jon, you and I'm sure many others out there, we've been on this journey of like engagement, right? And oftentimes, we're not really even sure what kind of engagement we're after. But like for us, like we're after this like intellectual engagement, not just behavioral engagement. We don't want just kids looking at us. We want them actively involved in our lesson. And it's been a real challenge for us until we started putting some pieces together. And for us, it all started with this idea of the Threeact math task by Dan Meyer. And, really just tinkering with that for a number of years before we started to kind of put the pieces together on what we could do consistently to ensure that our students were leaning in when we began that next math task.
For sure. We definitely were on that same journey, and I remember thinking that seeing some of his videos, and when we started to create our own videos, how curious I was, but also how curious my students became, and when we started to piece together how were you doing it in the classroom, and was I doing in the classroom, and also seeing it from other teachers, there's a lot of variability in how people were implementing Dan's tasks, our tasks. Definitely, I was implementing them differently in the beginning than I do now, for sure. And then I guess what we want to do in this episode is we want to help you skip some of the errors that we were making, and skip some of the tools or the routines that we think aren't as impactful as the one we want to give you today, which is about the curiosity path. So we want to outline that for you, and we want to give you some examples today, hopefully so that you can spark curiosity with your students.
Beautiful. Yeah. And if we go back right to the idea of that Threeact math task, and I think, maybe it's because I was that kid in school that really wasn't super interested in my English classes. Like that whole literature piece just wasn't for me. I sort of missed the message in the beginning of even like why we call them, or why Dan called them, a Threeact math task, but just this idea of using elements of storytelling. And I think anyone who knows a lot about storytelling could probably like piece it together a whole lot faster than maybe you or I did there, Jon. But like we initially were not very good storytellers. Like we would take these tasks and we would sort of, we'd play them sort of like out of the blue, oftentimes after we already like taught a lesson. So it was sort of like, we had killed some curiosity right away, because if I just did this like
Right.
lesson, and back in the day, it was like a note, right? Like it was like ratios and rates, right, would be the note. And then we'd play this video, and then I'd be like, all right, how are you going to solve this? And they're like, with a ratio
No
or
surprise
rate. Like
here.
it wasn't very, Yeah, there was nothing going on there. So these were, big things, and we're laughing it off now. But let's be honest, like, we were banging our heads against the wall for a really long time, not really putting that idea together. So what we've tried to do, and we've done a lot of learning about, how storytelling works, and really how we can make our math classes more like that idea of the storytelling piece versus making it about, just some video or some photo. It's actually like much bigger than
Yeah,
that.
for sure. And to get into this idea of storytelling, like think about our math lessons traditionally. Right now, when you think about your math lessons traditionally, you're walking into a new lesson. Kids are going to sit down. You're going to do job number one, which is always right, always to take up the homework.
Can't miss the homework, that's for
No, for
sure.
sure. And then job number two is I would write on the board the outline for today. Like today we're going to learn about this, and then we would give example after example after example, and then we would do like an application problem at the end, and that kind of stuff. Like thinking about that as a line of how a lesson would go, to how like, and then how do I modify that so it can spark curiosity? Like, and when Dan Myers, when we started using videos to spark that curiosity, that throws a huge monkey wrench into what kids expect of that lesson. So it's like it shakes up a whole lesson for sure when you decide you're not going to start and follow that that model of what a math lesson is supposed to be. So sometimes there's resistance for the students. First off, is that when you start changing that model of math, kids are going to be like, what is going on right now? And we want to,
Right.
we had this happen with our students for sure. Kids would be like, what do you mean you want me to do something different than take notes? And I just I guess to be clear is like it's going to happen if you, and that would happen anytime you change your routine for sure in your classroom. But I would say if any change like this that we suggest here today, stick with it, because with these changes allow your students to think more deeply about the math, and that's what we want. Like that lesson that I outlined, that traditional lesson was the lesson where I was doing all the thinking and they weren't doing the thinking. So we got a nice progression to change that so that they're doing more thinking early in the lesson. And it slowly builds up this idea of getting to math. And I think that's a great technique versus the old traditional lesson. You just dove into math right away, and you lost half your
Right.
kids right off the bat because they didn't remember yesterday's lesson.
Yeah, we're definitely creatures of habit, right? Like humans are creatures of habit, and I think the pushback we received too, to be very specific, was the more of our like high achievers that really didn't like it, and I think the reason, I didn't know at the time. At the time, I was like, ah, man, I better go back to what I was doing, because obviously the high achievers know what's best, and if this isn't going to work for them, then like, wow, I'm going to be really really in trouble here. But in the reality, it's like, well, those high achievers are the ones who like figured out the game, right? Like they figured out how to play the game of, copy down what Mr. Pearce puts up on the board. And, oh, I've noticed that on the assessment, like, the questions that he puts a big star next to happen to look an awful lot like the ones on the test. And, like these are all things that those students have like picked up on, and they know how to win that game. So for them, they would much rather just sort of continue doing things as is. But when you do this, you're going to be shaking things up. So let's
Yeah.
dive in here and let's talk a little bit about this curiosity path. Like first off, for us, and I've heard Dan say this before. I heard, and I think I've only heard it recently, simply because like I didn't know what I was listening for. Maybe initially, like I didn't have enough experience to maybe understand what he was getting at. But it's this idea of withholding information. So rather than us coming with this problem and giving kids everything they need, like that just completely sucks out all the curiosity. Like, let's start kind of like your win of the day you talked about, where you just had kids talk about, like, what are the major differences? You didn't, it wasn't like you let the whole cat out of the bag, like, here's what we're going to do with all this information. You just got them talking about it. So it's like a really low level of entry, and everyone can get in. And by just withholding information, you have a little bit of that, like, wonder, like you're sitting there like going like, like, what's going on here? I wonder what's coming next. And for some of those high achievers, that might make them feel uncomfortable initially, but again, sticking with it, I think there's a big payoff at the end, for sure.
For sure. And when you're thinking about withholding information, and if you have played, and when I say played, but I've, used one of our lessons from our, real world problems, or one of Dan's, or one of a variety of people's lessons in your class, and you've shown the Act 1 video or Act 1 image, and all of those really successful, those great lessons that generate so much discussion and get kids in right away are the ones that withhold the most information, and getting that, like, that's a key element. And so many people, I think, miss that about why something is curious. There's so many teachers. I've had many conversations with teachers. It's like, why do you think that lesson was so curious, or why did it spark something in your students to begin with? And a lot of them will say, oh, you used a video, Jon, like that video with you in it, or maybe it was that math problem that had a kid's name in it, and they were like, oh, it was awesome to see my name on the screen. I used to think that about, I used to do that for sure, put kids' names in it because they're going to want to learn more, and people think that's what makes something more curious than something else, but those videos that have been spread around, and the ones that we've been creating, and those ones that really make the lesson way better than the other ones, is the ones that withhold the most information.
Right. And it's like that withholding of information that builds this second part of the pathway, which is like the anticipation. So, we've tried to be general with our terminology in the pathway, so that people don't get confused and think that, I got to go out and film a video of something that kids are interested in, because I feel like I did that early on as well. Like, it was like I had to go, if kids are interested in hockey, I got to make sure that, the image or the video that I'm doing is hockey. And that's not really true. Of course, if you could find a scenario like that, that's helpful, but that's not what, like, hinges curiosity. Like curiosity doesn't hinge on that idea. It's this idea of, like, anticipating what is coming next. And if I don't withhold that information, then there's not really a whole lot to anticipate. So those ones are pretty close and tied at the hip. So if I can get them anticipating, then it gives us a great gateway to our next part of this pathway. And Jon, I'll let you unpack this next piece of the pathway, the third piece.
Right.
Here.
So if we have done a setup, like the withholding information, and to create that anticipation is like one of our teacher moves that has to happen before the lesson begins. So you have to make a conscious effort that you are going to withhold information, because once you give it out, like, you can't take it back. So we have to make that the beginning of what happened. Like, that has to happen first, where if we do that, that's what allows the next piece, which is another teacher move to happen, is we want to use what Annie Fetter's been sharing, which is notice and wonder. So if you've withheld information to generate that anticipation in your students, you can now ask them, what do you notice and what do you wonder from this image, or from this graph, or from this video that you've just watched that doesn't have quite all the information? And from that noticing and wondering, what I like to do with my students, I get the most out of this is if I do, most people call this a think, pair, share, where I have them on their own jot down things they notice and things they wonder under two different headings, from the image or the video or the graph or whatever we're looking at. And then after a minute of doing that, only a short time is all they really need to, in point form, write those notices and wonders. And then after that, after they've thought on their own, then share with a partner. And once they've shared with a partner, it's like they've got that out into the open. It's like they've validated, someone's heard their noticing and wonderings, and now it's
Yeah.
out into the open, and that makes it so much easier when I ask for the class to now share with everybody, because I get so
Right.
much more engagement. And I know that if I did not do it first, share with a partner, and I just skipped that part and went straight to, hey, what do you notice and wonder, kids, and expected them to say something to the whole class out loud first, I get way fewer noticing
Right.
wonderings as a class, and it doesn't seem to generate the discussion that I'm looking for.
Yeah, it's like you get crickets, right? And I think, there's a couple things going on there, but the big one for me is, it's nobody, it doesn't matter if you're an adult or if you're a child or if you're a teenager in a high school class, nobody wants to throw an idea out there before they've had like a bit of a sounding board,
Mm-hmm.
right? So that pair part before you share out to the room, it's sort of like you get that initial like reaction, and you get to sort of get this feedback like, oh yeah, like that's actually a pretty interesting notice or wonder, or if it doesn't go over so well with your partner, then you're like, yeah, maybe I won't share that one out. But the other piece for me that's big is just this idea that like every student can participate in this portion of the
Mm-hmm.
lesson. And what we're doing through this process by slowly revealing information and building that anticipation, then finally letting kids notice and wonder, is you're essentially, like, I hate to use the word trick, but really you're tricking the kids into understanding the context of the problem before the problem even arises. So it's like you could ask any kid in the room about the scenario and they all understand like the pieces of the puzzle before we even know what it is we're going to try to solve. So it's almost like everybody's put a little bit of that skin into the game, and then we could like write these things down and sort of like show kids that like everything that they say. And I always use the terminology, I always say anything and everything that you notice and wonder. Like I try to make it very clear that we are not looking for only math like type noticings or math type wonders. Like I want the funny kid in the class to come up with something. I want the student who, usually has their arms crossed and doesn't want to participate. I want that student to share something, even if it's something that, I don't want to say inappropriate, but like not very helpful. I'm going to write that stuff down. And then we can like then start looking at some of these things and go like, which ones, like which wonders here can we actually try to answer here? Like, what information do we need? And like, maybe like, which notice, like the things that you've noticed here, like, are any of these going to actually be helpful to us to answer some of these wonders?
Right.
And it just gets that discussion going so early, that mathematical discourse, so that when you do get to the nuts and bolts, the math, you don't have like crickets there where, it's the same three kids putting their hands up. It's like everybody's already like spoken in the room and they all feel like they've offered something of value. And that gives us this opportunity, this great opportunity to kind of take us to this last step in the pathway, which is this idea of giving them an opportunity to estimate or predict based on any of the wonders that you sort of
Right.
land on. So John, like tell us a little bit more, like how do you figure out like which wonder, we sort of go with as like a leaping off point, and then to set us up for this idea of like estimating or predicting. And I'll talk a little bit more about like why it might be an either or in that
Right.
particular case. But tell us more about like how do we land on a wonder?
Just before I get there, I want to go back to the notice and wonders just for a moment, because I know that there is some drawbacks to this, and like warnings that we can have. Like Kyle, what would be something that you'd want to warn people about, or what are some of those things that are like, these things can happen and we want to like let you know on how you might handle that? Do you know what I'm saying?
Oh yeah. Yeah, no, totally, totally. I mean, well, I mean, I know a couple mistakes for me with the notice and wonder is like limiting it I sort of referenced it earlier, but this idea of like anything and everything to me is something that I do now, because I used to say, sort of like, what might the question be? Or I might say, like, what do you notice and wonder mathematically? And like right there, it's just, you're just shutting out those most vulnerable students in our class that we're actually trying to like find ways to engage them. That just shuts them down. So those are some of the mistakes. What are some of the other pieces there, Jon?
I was thinking, like I always want to tell people that you're going to get, the first time you're going to do this, there's a couple things to watch out for that will happen, and it's okay that this happens. And one of those is you're going to get a kid who tries to test the limits. And this is what I think so many teachers are afraid of. They're afraid that if I ask notice and wonderings, who knows what the kids are going to say. And so like you're going to get a class clown that says, like, oh, and they make a joke. And I always just say, that's fine. Just roll with it. Write it down on the board, just like every other kid's notice and wonders. And that takes the power out of that student, and that's over. And the next time you do one, they're not going to write it, because they're going to want to write the one that you pick or the one that you settle on later. So that's something.
And that student there that you're talking about, like, it might even be something that may not necessarily be inappropriate, but sort of like, it could suck the energy out of the room, like, especially if they say it in a negative way. So for example, like, why are we even doing this? Like, they raise their hand, you pick that student. It's a student, the student who, tends to, cause a little bit of trouble here and there. And, you go, this student wants to participate. You call on them and they go, why are we even doing this anyway, or something. And it's like, you know what? Take it, you put it down. And I even try to like talk to that student about it, saying like, you know what, I might be thinking the same thing, like something crazy's going on here, like, what am I thinking? And just kind of play it off and really just try to look at it and not take it personally, because you're going to get some of that. Might be from a high achiever. It might be from maybe a student who tends to be a little bit more negative each day. But it's like over time that, you just build this culture, and it's how you handle those situations early that is going to kind of make or break your success here. Because if I take offense to it, or if I respond negatively, it's going to be really tough to, sort of take that chance to try one of these
for
again.
sure. And like you said, I welcome that question, and I write it down right away. And I say like, yeah, like, what are we doing here? Like you said, just play it up. Like this is weird, isn't it? And write that down, because what I do is at the end of the lesson, when we go back through these wonders and we answer the one that we settle on, and then I go to that kid in front of everybody and say, why did we do this? And every time I've done this, that kid will say, so that we could do this math question. And it was like, you've answered this, you put the why up, and they never need the why again. And if they do, we do the exact same thing, and it's no big deal. But I like that you said that creating the culture is so important, because that is another thing that we kind of overlook, that we think, someone, like we're saying, try this routine out in your class with a 3-act math problem, or a problem that withholds information. And you think this is going to be initially the savior of your engagement in your class in the math discussions. And it can be, let's not get that wrong. But what can happen is that you have to do this not as a one-off. It's got to be more of a routine, like you said, Kyle, that you have to create a culture where it's okay that kids voice their opinions and their concerns and their wonders. And so that's hard to do. And that's done with a routine of doing this on a regular basis in your classroom. If you did your traditional math lesson that we talked about, and then you decided the next day you're going to do a lesson like this, where you've been the person that always did the talking and always questions are right or wrong, and you don't open the floor to this, it's probably not going to be as smooth as you liked. And so it's something that you have to do over and over and over again, and it will become a custom in your room.
Yeah,
I,
totally.
I know there's one more thing we should warn people about, which I always think, and I know that you alluded to this earlier about high achievers. There's it's the high achievers that are going to resist this the most, and I know that you've experienced this. Want to tell us a little bit about that?
Yeah, I actually like one the story I tend to that sticks out in my mind was a student in my class. It was a female student, a grade 9 class. She was the top student. I want to say it was every year in her elementary school, but I know definitely in her grade 7 and 8 year, and came into the class, and it was like she was not happy with the way I was leading my lessons, and at first I didn't understand, like what the issue was. And it really bothered me because, like I said, it's like I respect my high achievers opinion, because I'm like, well, they're doing well here, so like I must be doing something wrong. And it took me a little while. After a few weeks, she sort of let it go. But really what it turned out to be, and I eventually kind of put the pieces together, she was not comfortable being outside of that realm of like comfort in knowing that, like, if I just copy the note down and I do the thing that I always do, which is like just sort of memorize the problems that I'll likely see. Like, she was not comfortable with this like uncertainty, especially early in a lesson, where it was like that anticipation was almost killing her in a way, and like she needed to sort of build up this resilience, because she actually wasn't showing a growth mindset. She wasn't showing that resilience. And after a while, I realized that, like, this student really was struggling with the inability to outperform her peers early in a lesson. And like, when you think about every other class that I ever taught before doing this stuff, like before actively trying to change how I taught my math lesson, I was essentially creating an environment where the top achievers could very early in a lesson outdo their peers, because it was all very answer driven. It was very like, here's the problem, solve the problem. And nobody else would want to solve it, or any of the students that didn't feel as comfortable with the math wouldn't even attempt it, because all of the keeners would have their hands up before too long. And with this process, everybody's on the same level playing field. And this particular student, I think in her mind, it was like, I don't think she explicitly knew that she was acting this way, but I think, like, to her, it was like, this is the thing that I'm better at than everyone. And you've like taken that away
Mm.
from me. And I think there was this like fight or flight response that she had. And it took a little while, but she eventually came around, and she did admit to me that she felt like she actually understood the math, and she actually felt like she like could solve problems, like actual problems that I didn't pre-teach her to solve, which was like a huge relief to me, because if she left my class not saying that, then I would have always wondered whether she just really despised this method or not. But she did come around, and it is something that I wish someone would have told me, but I experienced it myself, and luckily things worked out in the
Yeah,
end.
very true. I've had very similar experiences, but never really thought about it the way you just said about taking, um, that student thinking that you're taking this away from me, and this is what I have in this class. Very, very interesting. Appreciate that story. Thinking about this curiosity path, we started with, we can create curiosity by withholding information from pretty typical problems. Also, those video problems do that. That helps create anticipation, which leads into allowing you to ask your students what they notice and wonder, which helps drive which question you want to settle on with your classroom, and that's the purpose. It's you're kind of giving off this look that you're allowing your class to choose the path for today on what we're going to study, and think about that. Like, no other math class do you usually do that. It's like the teacher says, we're going to do this, we're going to do that. And this gives off, like, kids start to feel like they have some power here. Like, I'm going to feel like I'm going to choose the lesson for the topic for today. Because if a kid says, you know, I notice that the number of sticky notes that are going on that wall is 113, and another says like, I wonder how many sticky notes are going to cover that. But another kid says like, I wonder how fast they'll cover that. One kid's thinking already like rates and thinking of going down that path, and another kid's thinking about area in covering a surface. We're wondering like where we're going to go. And you as the teacher, and this is for me, like there's many different approaches to this, right, Kyle? Like there are many teachers that might go exact like where all the kids go eventually. Like they'll go down that path and then they'll go down that path.
Right.
Me in my high school class, I will carefully select these kinds of problems because I want to attempt or I want to tackle a particular learning goal in my class. So I will kind of have one. I have my one topic picked out, and I will pick a kid's wonder to explore that's closest to the one that I've picked out. Like for example, in the task where I mentioned where we're putting your kids are watching sticky notes getting put along the wall, and a kid says, I wonder how many sticky notes are covering that wall. That's the question that I'm hoping someone will answer, or sorry, ask, so that we can say like, Katie asked this question. Now let's go and explore. We can go and explore that question, and she feels empowered today. And that's a great thing to happen in your class too.
Yeah, and I think it's great. We didn't mention this, but with the noticing and wondering, especially early in the year, this might change as time goes on and as that culture is created. But initially, like we're jotting down like all of these noticings and all of these wonderings. We're like putting kids' names. It's a great way as well to like learn the names of your students, because like you're going, oh, and your name again, and you're writing it down on the board, and you're like you're helping yourself kind of like build a relationship with the kids, but at the same time you're empowering them and showing them that their voice matters. And like you said, it's like you've got this learning goal in mind, and of course in certain cases you're hoping like a specific question might come up. Sometimes it doesn't, and that's okay too. So you have to decide and anticipate ahead of time, like what are some of the noticings and wondering students might come up with, and are there any others that you might be able to work with that might not have been your initial intent that would still allow you to get at the learning goal or the learning intention that you had in mind. So like you said, Jon, like there's so many different ways that you can do that. Everyone's got a different sort of style. I'm going to suggest, at least for me, and I think you were much the same based on our previous conversations, that early on I was like, I did not want to like be very flexible because I wanted to make sure the lesson went okay. And I was so nervous about, doing it quote unquote right. So for me, like I've got these questions in mind, and sometimes, it's okay too if you as the teacher get to pick the question too. So, we don't want to leave this as like, it's so open where like, who knows what you're going to actually be teaching that day. Like you definitely want to have learning goal in mind. But the benefit is maybe that by answering one of the questions, you might be able to address some of the others as well. So giving like students that, at near the end, when you answer one of those problems, like, are there any others that we might be able to answer now based on what we've just done? Like, what else do you need? And again, that's another way to sort of empower those students and let them know that, it was a worthwhile exercise to share your notice and wonders. It wasn't like we were just, doing it to appease them. And once we land on that wonder that we want to work with, that's where you give them another opportunity to again engage in that mathematical discourse, that thinking, by giving them, if it's a problem that they can make an estimate because they can spatially see a quantity of some type, or predict if it's something that, maybe there's not, there isn't a quantity like visible, but, they're going to make a prediction based on some sort of prior knowledge. Like this is another opportunity that, kids can turn and talk, and then, do that think, pair, share piece where, you can get all kinds of predictions out in the open. And really, like, I'm going to call it a bit of a math fight. That's, terminology I know you use, and some others in the math space use quite a bit, but you can get some pretty pretty passionate students when they toss out a prediction or an estimate and it's like way off from their neighbor and they're kind of looking at each other like, what the heck are you thinking? It really gives you like an opportunity for them to really like bite into this problem and really
Yeah,
want to solve
especially
it.
that prediction piece, which is the fourth piece of the curiosity path. Um, I really like to prolong that part when we get those predictions out there, because some students have a hard time making that those predictions, and it's great to start off with asking kids, like, give me a wrong answer first, and like, what's not right, and you can classify that not right answer by saying, like, what's not right, that's too low. Like, if we're talking about that sticky notes on the wall, how many do you know is not the right answer? And a kid's going to say, well, like 2 is not the right answer. And so you're like, yeah, we know 2 is not the right answer. I wonder how risky you can get with the too low. And you'll start to see kids go, and there's wheels are spinning about how much they can bring that too low up before it becomes too risky for the actual number of what they want to predict. And then you can do the same for a too high. Like, what's too high? A million's too high. We know a million is too high. Let's be risky. Bring it down. Like, how risky can you get with a too high? And what you're doing, the kids are framing in reasonable responses, reasonable answers, which we don't do a lot when we're talking about problem solving. We don't frame in, like, what are reasonable responses, so that when I get an answer out of this, does it follow my reasonable responses or not? So having kids predict
Right.
allows them to put that box around what the reasonable responses will be. So, and then they can make a nice prediction inside that box. And then compare it to the rest of the class, which generates like even more discussion about number sense, about the concepts involved in kids. And what's happening here, which I always find what's happening here that gets overlooked, is kids are starting to problem solve. They are starting to think about, how can I get my prediction more accurate? What will I need to go further in this problem?
Yeah, and the beauty too, and you hit on it there, this idea that they're already like in that problem solving process, and they're thinking, and like depending on the questions you ask students and what they share, like when you ask them like why did you come up with that estimate or that prediction, depending on the scenario, when you ask them to explain, it gives you like a window, like a diagnostic into their thinking. So, depending on the problem, like, are they thinking like multiplicatively? Are they thinking additively? Like what is going on in their brain? And we haven't even introduced we haven't given them enough information to actually do any sort of calculation or any sort of like formal procedure. So it really gives you like that window into their thinking. And Jon, I've heard you say this a number of times before, and it's something I think about a lot now. And it's this idea that after like all of these students like give these predictions, they have their own high and low, like you said, and then they like narrow in on like what do they think like their best prediction, their best estimate is, and then they share that all out, and then it's like all of these best guesses or best predictions are shared out, and it almost like frames like that border for the entire class, that range for the entire class. And then this is where you drop it on them and say like, the power of math, like the next thing that we're going to do is we're actually going to try to like zero in on a more precise approximation. And in many cases, like a very, very precise approximation. But like this idea that oftentimes textbooks lie to us, and that, the situation is very static, when in the real world, there's like so many different factors and extraneous variables. And, so this power of math is to take this like estimate that we have and look at that range, and to be able to like zero in and become even more precise. And that's when you have them like hook, line, and sinker, and all the students are there just kind of waiting to dig in. They've already been thinking about like the stuff that they want to know. And now you ask them like, what do you want to know from me? Maybe I'll give it to you. I always tell them, maybe I won't. But then you get to kind of hear from them. Like, what do you like, if you want this piece of information, why? Like, what do you want to do with that piece of information? Or if you want this piece of information, like, what were you thinking? And it just gives you like so many options where you get to decide what to give them next. Again, for me, I have like all of that like thought out ahead of time. But as you get more comfortable, you might be able to pull a little bit of a modification based on where the conversation's going. So depending on how flexible you become with this process.
It's a very powerful moment when they make a prediction and then you ask them what they want to know and they can tell you, and they've just done some problem solving and you haven't even given them the information yet. A huge thing. And if you think like, why don't we just skip to the prediction piece and skip all that other stuff that we talked about, the first three? If you did that, it wouldn't be that powerful. You need to go through the withholding information. Like, you need to withhold the information so that they can anticipate first, and the noticing and wondering slowly builds to that estimation. Like, it's that storytelling aspect that we started the top of the show with, and it's unfolded here in a math lesson.
Yeah, no, beautiful. Beautiful. Well, like, once again, I want to, I know I'm looking at the time here, John, and we are like, I feel like every episode's going to be like this, because once we get going, we just like talking, and you know, I hope folks have found this valuable. So just to quickly summarize, like, our curiosity path, this one of many different ways that you can spark curiosity in your math class, this idea of like withholding information, like don't give too much up front, just like sort of drip feed this information out there to build that anticipation. Ask kids to notice and wonder, and give them the time to do it. I know we're so rushed to get through curriculum, but like, let's slow down a little bit and let the kids notice and wonder. And I think you'll be amazed at what kids come up with, what they notice that you never noticed, and what they wonder that you thought like they might not actually care about. Like, they actually are curious. Like, we're naturally curious. And then finally giving them this opportunity to throw out estimates and actually use some of their problem solving skills, and to build and sharpen their estimation skills. That is one of those key pieces for sparking curiosity from our 3-part framework. So, John, what are you saying about these first few episodes? Give us a little bit of a summary. Where are we going next?
Well, these first few episodes, we've been going back and forth. Last episode 1 was about, you know, the introduction to us and to the framework. This one was about our number 1 tool for sparking curiosity. Our next episode, which is going to be episode 3, we're going to dive into how we can fuel sense making, and what can we do in there to bring in that thinking out into the open. So we're going to give you some go-to tools to fuel sense making in your classes. I believe episode 4, we're going to unpack some of our teacher moves, a few of them, to get you moving on some of this stuff.
Beautiful, beautiful. And then keeping in mind that after those next couple episodes, we are going to have some folks from the math education space coming in. We don't want to mention any names yet. That'll be a surprise for you, as well as getting some folks just from the math education community in general with some challenges that I think we all tend to struggle with. For some, it's about like differentiation and meeting the needs of all the students in their classroom. For others, it's about like, you know, the little intricacies behind sparking curiosity, or parts of this 3-part framework. So in order to make sure you don't miss out on any of these new episodes as they come out each week, be sure to subscribe on iTunes, on Google Play, Stitcher, whatever podcast platform that you're using. And also, if you're liking what you're hearing, you could do us a huge favor to make sure that this message gets out to more math teachers around the world by sharing this podcast with a colleague, and by leaving us a review on iTunes. We would really appreciate it. All show notes and links to resources from this episode can be found at makemathmoments.com/episode 2. Again, that's makemathmoments.com/episode 2. And John, what can they do until then if they don't want to wait for the next episode?
So if you're not interested in waiting till episode 3, why not watch our 4-part video series to help build resilient problem solvers who don't want to stop learning when the bell rings? You can find that free 4-lesson video series at makemathmoments.com/lesson1. That's makemathmoments.com/lesson1. Well, until next time, I'm Jon Orr.
And I'm Kyle Pearce. High fives for us.
And high fives for you.